Hello everyone, this is Siddharth, and today we will be solving another question on leak code, which is minimum size subarray. So, what we have to do in this problem, we have given an array and we have given a target, and we have to find the smallest subarray which whose elements add up to the target value. So, let's first discuss the brute force method, and after that we will be discussing how to solve this question using uh, efficient approach. So let's move on to the screen so that we can discuss the brute force method. So in the brute force method, what we will be doing, guys? We will be initializing three loop. So this loop, the outer loop, will take care of the element from where we have to start checking the subarray. So after that, this next loop will be this next inner loop will be checking the this will setting the outer boundary of the subarray. Let's see how. So initially I is 0, j is also 0 and k is also 0. So for I is equals to 0, j is 0 for this loop. So after that we will come to this loop. In this loop what we will be doing, we will be adding the current element to our sum. So our sum become 2. After that, as sum is less than our target, we have to move on to the next element. But as k is less than as after this the k become 1, which is greater than j, so we have to move on to the this loop will get over and we will move on to the to our first loop, which is this one. So after that, again our sum becomes 0 and we will start for j equals to 1. J equals to 1, we will start from k equals to 1, k equals to 0. So for k equals to 0, we will add 2 to our sum, so our sum become 2. Now k will become 1. Now for k equals to 1, sum is already 2 here. Now we will be adding 3 to it. So now sum becomes 2 plus 3 is equals to 5. So still, so target is 7 here, guys. Still the sum is less than 5, so we will move on. But as k become greater than j after this, so we have to again this loop will get over. We will move on to our outer loop. So now let's do partition here. So after this, what will be happening? Now our j will come 2. Now we will again start from 0. So k equals to 0, sum will become 2. Again k equals to 1, sum will become 5. Now k equals to 2, sum will become 6. Again k will become greater than j, so we have to move on to our outer loop. Now j will become 3. Now k equals to 0, sum will become 2. K equals to 1, sum will become 5. K equals to 2, sum will become 6. K equals to 3, sum will become, for k equals to 3, we have to add 2 more. Now 8. So now this is greater than a target. So this is the, if we start from 2, this is the smallest subarray whose sum is add up to target. So we have to update our minimum length to this much, which will going to be max dot minimum of max dot minimum length, same minimum length, and j minus I plus 1, because here j is 3 and 0 1 2 3 and I is 0 plus 1, which will going to be 4. So it is giving us the right answer, guys. So we will be uh, we will be initializing our length value, minimum length value, to 4. In this manner, we will check for 3, then we will check for 1 until we will check for 3. And in the last, we will be having the smallest possible length of the subarray. So this is the brute force method, guys. But this method will take omega of n cube of time complexity. So obviously we have to optimize this. So let's move on to the efficient approach. So in the efficient approach, we will be using only single outer loop, and we will be using sliding window technique, and we will be able to solve this question in omega of n time complexity and constant space. So let's move on to the coding part. So okay, so there's the concept will remain same. Some concept will remain same. We will be initializing two pointers left and right. Right will take care of the outer boundary, and we will update our window using left pointer. So let's see. First we will creating a current sum variable. Current sum equals to 0, and we will be initializing our minimum length to integer dot dot max value, and now we will be initializing a left pointer to 0. Now we will create a loop int right is equals to 0, right less than nums dot length right plus plus. Okay, after this what we will be doing, we will be calculating a current sum. So current sum is equals to sorry, plus equals to array nums right. Now as we are using this loop, we will be setting our outer boundary condition, and from where we have to decrease the side of our window as soon as our sum become greater than target. So we have to check for if our current sum will become greater than equals to target. What we have to do, we have to update our minimum length, which will going to be math dot minimum of min length gth, and what will be the size, it will going to be right minus left plus 1, which is same as the two outer loop condition, three loop condition, where we have calculated the length as I minus j plus 1. So here we are calculating the length in the same way. So now we will update our, after updating our minimum length, we have to make our sum. Current sum is equals to nums left. Just wait a minute guys, after that you will understand why I am doing this. So after updating our window and minusing our current sum, we have to increment our left counter, and in the end what we will be doing, we will be returning our minimum length. So return its minimum length is equals to integer dot max value. If this is the case, so we will be returning 0, otherwise we will be returning a minimum length. Okay, so now the code is completed guys. So why I have done this? So first we will be calculating our current sum from the current element. So let's move on to the screen. So first, suppose this is our array guys, 2 3 4 2 3. So we will be starting from 2. We will be adding this to our sum. We will be adding each element unless we find our sum greater than target. So target is 7. So we will add 3 to this. So now our sum become 2 plus 3 is equals to 5. Now we will add 4 to this. Now 5 plus 4 will going to be 9, which is greater than our target. So what we will do now, we will again start from 2 and we will decrement our window from here. Currently our window is here. Now we will start from uh, 0th index and we will try to decrement our window, and we will try to find the minimum length because we want a minimum subarray. So after that we will subtract this 2 our sum, and our sum become 4 plus 3 is equals to 7. So this will going to be the minimum subarray whose sum will add up to the target value. So that's why we are updating our uh, that's why we are calculating our minimum length, and we are updating our current sum by minusing from the start, and we will incrementing our left counter, and here we will be returning our minimum length. If our minimum length is equals to integer dot max value, this means that we haven't find encounter any subarray whose sum is equals to target, then we will be returning 0. Otherwise we will be returning our minimum length. So let's try to run this code. So let's see if it will work fine. Okay, there is some mistake, guys. Let's see. So we have initialized our current sum, then we have initialized our minimum length to integer dot max value. Start from left. Current sum is equals to nums right. Now current sum is greater than or equals to target. Then we will not show minimum left, right minus left, because this is setting the outer boundary. So we will minus right minus left plus 1. Then we are updating our current sum to nums left. We are incrementing a counter. If our minimum length is integer dot max value, then we will be returning 0. Otherwise we will be returning length. There is the mistake. Okay guys, so this is the mistake, and consciously I have added this here. This will be while. So let's try to run this code. Okay, so let's try to submit this now. So we have successfully solved this question. So bye, see you in the next video.